real-world mathematical applications. In order to do so, we were required to humiliate ourselves in public.
The geometric mean between two numbers is the positive square root of their product. The geometric mean between 4 and 9 is 6. If 4 over x is equal to x over 9, then we can cross multiply and get 36 is equal to x squared. If we take the square root of both sides, we get x is equal to 6.
Geometric mean can be used to find the altitude or the base of a triangle. Theorem 8.1 states that if the altitude is drawn from the vertex of a right angle to the hypotenuse, then two similar triangles are formed.
According to Theorem 8.2, the altitude from the right angle of a right triangle to the hypotenuse is the geometric mean between the two segments formed.
In this example, we are using the given information to find the altitude. We can set up the proportion 6 over x equals x over 2. After we cross multiply, we get x squared equals 12. Now we find the square root of both sides and we get approximately 3.46 feet. Alright, now that we know how to do this, let's see how we can apply it to a real life situation. There is damage at the top of the flagpole. Sarah is standing 11.25 feet away from it, and the telephone pole is 20 feet away from it. The angle from Sarah to the top of the flagpole to the bottom of the telephone pole is 90 degrees. We can set up the proportion 20 over x equals x over 11.25. We now cross multiply and get 225 equals x squared. Then we take the square root of both sides and get 15.
Now let's learn about the Pythagorean theorem. Theorem 8.4 declares that in a right triangle, the sum of the squares of the measures of the legs is equal to the square of the hypotenuse.
Theorem 8.5 states that it's only a right triangle if the leg squared equals the hypotenuse squared.
Now let's look at an example.
The triangle's leg lengths are 5 and 10 centimeters. We need to find the hypotenuse. We can plug 5 and 10 into the equation a squared plus b squared equals c squared and get 5 squared plus 10 squared equals c squared. 5 squared is equal to 25 and 10 squared is equal to 100. 100 plus 25 is 125. So we have 125 equals c squared. If we take the square root of both sides, we get 11.18 centimeters. Finally, we can see how to use this in a real-life situation. Not only will we find the hypotenuse, but we'll also verify if it's a Pythagorean triple. A Pythagorean triple is when there are three whole numbers that satisfy the equation a squared plus b squared equals c squared. Let's go. The tree is perpendicular to the ground. I want to tie my clothesline from the top of that tree to the bottom of that tree. I know that the three are 6 feet apart and they're 8 feet tall. How long is my clothesline? The distance between the trees is 6 feet and the trees are 8 feet tall. We can plug 6 and 8 into the equation a squared plus b squared equals c squared and get 36 plus 64 equals c squared. This equation equals 100, so we can take the square root of 100 and get 10. This is a Pythagorean triple because all three lengths are whole numbers. There are two different kinds of special right triangles. A 45-45-90 triangle is one of them. A 45-45-90 triangle has the angle measures 45 degrees, 45 degrees, and 90 degrees.
Theorem 8.6 states that in a 45-45-90 triangle, the length of the hypotenuse is the square root of 2 times the length of a leg.
Now let's do an example. Both of the legs are equal to each other on a 45-45-90 triangle. So if this leg equals 10, then this leg also equals 10. The hypotenuse equals n root 2. So if we know that n equals 10, then the hypotenuse equals 10 root 2, or 14.1. We can also solve for n if we know what the hypotenuse is. If it's equal to 38, we can do the equation 38 equals n root 2. Now we divide both sides by the square root of 2 in order to get the variable by itself. 38 divided by the square root of 2 is equal to 26.9. Now let's see how we can apply this to the real world.
This lighthouse is approximately 150 feet tall, and it's really windy out, and I need to know if I'll be safe if it falls.
Angle from the top of the lighthouse to Sarah to the bottom of the lighthouse is 45 degrees. The lighthouse is approximately 150 feet tall, and this angle over here is 90 degrees. So we know that this is a 45-45-90 special as well as this side, then we know that x equals 150. Now, let's solve for y. If this side is n root 2 and n equals 50, then we can plug 150 into n root 2 and get 212.1 feet. Now we can conclude that Sarah would not be safe if the lighthouse fell.
Theorem 8.7 states that in a 30-60-90 special right triangle, the length of the shorter leg is half the distance of the length of the hypotenuse.
It also states that the longer leg is the shorter leg times the square root of 3.
Let's look at an example.
In this example, the shorter leg is n, the longer leg is n root 3, and the hypotenuse is 2n. We know that this leg, n, is 4, so we can multiply 2 times 4 to get the hypotenuse. This calculator does not multiply, so we'll just add 4 plus 4. We have 8. So now we know that the hypotenuse is 8. Now what we have to do to find the longer leg is plug 4 into the expression n root 3 and get 6.93 approximately.
Now let's look at a real life situation. This telephone pole is about 40 feet tall. I want to connect a support going from the top of the pole to the ground at a 30-degree angle. How long should my support be?
The longer leg of this triangle formed is 40 feet. That means that n root 3 equals 40 feet. We need to solve for n in order to find 2n, or the hypotenuse. If we divide each side by root 3, we get 40 divided by the square root of 3, or 23.09. So we know that n is 23.09. We can now multiply that by 2 and get 46.18 feet as the hypotenuse.
So, SOH is the ratio of the opposite leg over the hypotenuse. CAH is the ratio of the adjacent leg over the hypotenuse. TOA, tangent, TOA, is the ratio of the opposite leg over the adjacent.
Now let's look at an example.
We're going to use cosine in this example because we're trying to find the adjacent side and we know the hypotenuse. We can set up the equation cosine of 38 equals x over 14. We then multiply each side by 14 and get 14 times the cosine of 38 equals x. This equals 11.03.
Now let's look at a real life situation.
Sarah wants to throw this stick through the window. She's only able to throw at a distance of 23 feet. If the angle she's throwing at is 52 degrees and the window is 20 feet high, will she be able to make it? We can set this problem up by using SOHCAHTOA. Because we're trying to find the hypotenuse and we have the opposite side, we can use sine. Sine 52 equals 20 over x. Then we multiply each side by x and divide each side by sine 52. Now we have x equals 20 over sine 52. Now if we type this into our calculators, we get 25.38 feet. Sarah will not be able to throw this one.
We can use the inverse of sine, cosine, or tangent to find the angle measures.
In this problem, we're going to find the angle measure. Because we have the opposite and adjacent side lengths, we're going to use inverse tangent. We can set up the equation inverse tangent of 14 over 22 equals x. Now we can punch this into our calculators and get about 32.5 degrees.
The angle of elevation is the angle between the line of sight and the horizontal line when an observer looks upward. Here's an example.
If we were to find the angle of elevation of this problem, we would use the inverse of 150. Now we would set up the equation inverse tangent of 19 over 84. So now we know that x equals about 12.75 degrees.
Let's look at an example of a real-world application.
I'm trying to kick a field goal. I know that the distance from the ground to the horizontal post is 10 feet. The distance of the two vertical posts coming off of that is 10 feet as well. What is the minimum and maximum angle of elevation that I would need to kick it at for it to count?
If we add up the total height of the poles, we get 20 feet. Now we can calculate the maximum angle of elevation. Inverse tangent of 20 over 32 is approximately 30 degrees. Now we can take the bottom height, which is 10, and use the inverse of tangent. Inverse tangent of 10 over 32 is about 17.4 degrees. Now we know that Sarah would have to kick the ball at least 17.4 degrees and 32 degrees at most.
Shout out to Tom Brady for letting me use this ball. The angle of depression is the angle between the line of sight when an observer looks downward and the horizontal. Here's an example.
Sarah and Anna are standing at the top of two different sand piles. Sarah is 30 feet higher than Anna. When Sarah looks down at Anna, she tilts her head at a 35-degree angle. How far away are they from each other now? We know that this angle is 35 degrees. That means that this one is also 35 degrees. We're now going to try to find x using sine. Sine 35 equals 30 over x. We got this equation by using SOHCAHTOA. Now we want to get x by itself. In order to do so, we need to multiply each side by x. Now we have sine 35x equals 30. We divide each side by sine 35, and we get x equals 30 divided by sine 35. So now we know that the distance from Anna to Sarah is 52.3 feet.